So this question, first time what happens here? So first in this question what we'll try to do now, simple logic here. So here in a first key, just after closing what happens, it will not allow any current, it will be open circuit. But after some time what happens here, it will allow the current, complete current it will be allow, then it will be a normal wire type it will behave. Clear? You understood that, right? So now same sort of question, one more question we'll try to solve. Okay, write down this question. What is this question here? Can you see the figure? Switch off this lights, this lights, that light out, that light out. Right. Now question is simple here. It is LR circuit, but LR circuit la L and R are series in. Now what is it? They are in parallel. Yes or no, Google? They are in parallel. Draw the figure first and try to give the answer for me. So figure shows a L and R connected in a parallel to a battery through a switch. Okay. The resistance are same as that a conductor makes L. The two identical bulbs are put in each arm of the circuit. Means yes or no? We have two bulbs also. P is also bulb and Q is also bulb. Now which of two bulb light up earlier when S is closed? When switch is closed now, which one will be light up first, buddy? Which one will be light up first? P and Q, which one? Because immediately the current will not flow through this one. Yes or no? The immediate increment of current won't be there. If you try to increase, it will also increase. Yes or no? So what happens? P will not glow first. Then who will glow? Q will be glowing first. Then what about the second one? Second question. Will the bulb will be equally bright after some time? Yes. Yes or no? Of course it will be after some time. It will allow current and it will behave. Inductor will be a normal wire. Are you getting my point here? Simple, right? So earlier, what is that? Immediately after switching on, the bulb will be what happens here? Glows more. Okay, which one will be first one? P. Q will be glowing first. Then a P will be lagging because current will lag in the inductor. Right? That's why in our home also when we switch on, if the wire has a winding inside it, what happens? It will not glow earlier. Which one will go glow earlier? Which has a straight wire. Clear? So it will take time or not? So like that. Then buddy, any doubt? Any difficulty? No, right? Simple one. Tell me. No, madam. 4 o'clock. I'll meet. I'll meet. Shall we start, right? Can we do other question? Now this question, just try to draw the figure first. It is motional EMF concept. Yes or no? When this is there, AEEE 2015. So what is the answer could be? Which rule you are going to use? Right hand rule. Use it and tell me the answer. Anubrinta, come this side. Come here. Both of you. Anubrinta and one more Brinta also. Both Brintas, come here. Nowadays I see many people in lab they will be taking advantage of doing math homework, okay, preparation of chemistry, project work of English. So now tell me what is it buddy here? This U tube means B tube is there and A tube is there. Yes or no? Both are actually moving in a direction, right? Now can you just tell me, imagine yourself, if I take the B, can I take B now? So what is it here? I have to use a right hand thumb rule. Right hand flaming rule I will use it. Conductor is moving which direction here? Left direction. Yes or no? And magnetic field is inwards. Like this only, no? And current direction is which direction? Downwards. Am I correct? So the induced current direction is downwards. Okay. What about this one now? This one, A, upwards. Yes or no? How they are? Upwards. Means, can you understand these things? Upwards. Now what is the total current will flow through this one? Will it stop anywhere? Will it stop? No. The complete current will flow or not? Are you getting my point? Yes or no? So what is it here? EMF. So this entire diagram will behave as like this, like a circuit. Yes or no? So what is that circuit now? Like this. So this is also cell current is going in backward direction. Like this. Current is going in this manner. So this will be positive terminal. This is EMF 1. And what about this one here? Current is actually going in this direction, clockwise direction. So what is this one here? EMF 2. Yes or no? So both EMF is what is it here? Added or not? Yes or no? E net is equal to EMF 1 plus EMF 2. So you know already what we do. It doesn't matter whether it is curved or not. It doesn't matter. For us, we only take the length of this one. Yes or no? How much ever the length, that length only we will consider as a BLV. Yes or no? EMF is nothing but what is it? BLV. How many lengths are there here? 2 times. Yes or no? So both EMFs are what is it here? BLV plus BLV. Total answer will be what is it now? 2BLV. So which answer is correct now in this one? What it? Do not confuse. If such sort of question comes now, relax and check with your right hand thumb rule, right hand Fleming's rule. You will get an answer for it. Clear? So this is given in a AEEE. What is that here? AEEE 2015, 2005 they have given already. Right? Shall we move on now? Is it okay? So this tube is moving in left direction. This tube is moving in a right direction. Clear? Harish, you come front. This Harish. Where is that one more Harish? There is a chair here. There is a chair. Where is one more Harish? There is a chair. Left. Do this question because I am doing n number of questions from EMF also, motional EMF. This time I am gonna give a motional EMF onwards till end, whatever we discussed till today, whatever we taught. Chalo, draw this figure and try to find out the answer for it. Yes or no? First, what is it? I am gonna calculate motional EMF. You calculate. Find out. Motional EMF formula is what is that here? BLV. But they are not giving you, they are not asking you BLV, but they are asking you what? A square metallic wire will be there, resistance 1 ohm is moved with the constant. See, metallic loop itself 0.1 meter and resistance was how much here? 1 ohm. Means this metallic itself giving how much here? 1 ohm. Right? Then with the constant velocity and magnetic field is also given in the figure. Magnetic field perpendicular to the plane, okay, of loop. Loop is connected with a network of resistance, okay, we know already. What should be the velocity of the loop so that the steady current 1 mile, what is that, right? Milliamperes is in the loop. V value need to find out. It's a combination of current electricity as well as a current electricity as well as EMF. EMI. Can you all see the diagram? Is it clear? So what is this bit? What is this body? What is this connection? You tell me. Wheatstone bridge or not? So we know that current is nothing but what is that here? Induced EMF divided by R equivalent first. That is equal to what is that here? BLV. Can I write it? Son. Now can I use this formula? BLV divided by R equivalent. I will write it. Right? This is a Wheatstone bridge. So middle one can I cancel it? Yes or no? Yes or no? So if I say R dash equivalent, I will write it. R equivalent, what I will get it here? This is a bridge. Like this is a bridge. So in this one, obviously you know already. Try to solve yourself. This middle one will be cancelled because this one and this one all are 3 ohms only. So middle one I can easily cancel. After that, what it will become? These two are in series. 6 ohms. This one is how much? 6 ohms. Okay. After that, what can I do? R equivalent is equal to R divided by N because they are identical only. So 6 divided by 2 times. Totally how much here? 3 ohms. But R dash equivalent will be what is it now? Network of resistance R equivalent plus R of what is it here? Loop also I need to consider. Am I correct? What is it here? Totally it will come 3 plus 1 will be how much here? 4 ohms. Right? Finding resistance only important here. So you got already current. So I is equal to, I use the formula BLV divided by R dash equivalent. Now substitute values and give me the value of it. V value find out. Really? Let me check. So can I write I into R equivalent dash is equal to BLV? I value is how much here? 1 milliampere. 1 into 10 power minus 3 ampere. R equivalent is how much here? 4. B value is how much I gave you? 2 Weber per meter square. L value is how much here? 0.1. 0.1 means what is it? 10 power minus 1. and we have a velocity v. Calculate. How many times it will cancel? 2 times. This is how many times here? 10 power minus 2 times. So voltage is equal to, I am getting it as a 2 into 10 power minus 2 volt or else 0.02 volt. Is it correct? Sorry, it's not voltage, it is, what is this? Huh? Velocity, buddy. It is velocity, not volt. So what is the answer? I will get it here, meter per second. Here also meter per second. You got the same answer? Same answer है different Shall I move on? Can you do this question? By your own you have to do it. Do it. Do not discuss. This is a rod. Can you able to see this one? This is a rod. Okay. Which rule I should follow for it? Can you just tell me? What I am having, what I am asking you here? Force needed to move the rod in an indicated constant velocity of the speed is how much here? 2 meter per second. Which rule I should use it here? Which direction force will act? First that you tell me. Left hand rule. What should I use here? Left hand rule. Index finger is inside. Yes or no? The current generated. First let's see current generated. Then you come to this one. Current, which direction current will generate here? Magnetic field. Direction. Up direction. Yes or no? Motion of current in which direction? Right? Up direction. Current will be in like this. Am I correct? Then what about the force direction? Magnetic field left direction your finger and current is upside. So force which direction it will act here? Left direction. So no. Magnetic force formula do you remember? Which is a BIL. But I is what is this here? BLV divided by R into L. So total answer will be what is it here? B square L square V divided by R, which is a F magnet, which is F magnetic field, which is also required flows. So can you solve it? How much? B value is how much here? 0.15 whole square means 0.1515. Can I write it like that? And then L is how much here? What is the length of this rod? Did they mention? Length of the rod they didn't give up. No, 50. I cannot see that. I think I have to check my site. Velocity is how much here? 2 divided by, and R is how much I gave you here? 3. Give me the answer, buddy. Give me the answer, buddy. What is the answer? Which answer is correct? You have to tell me. Can I write this one as 15 into 10 power minus 2? 15 into 10 power minus 2. Do it. 1, 2. This one cancel. This is 5. Now total answer will be 5 into 2 will be how much here? 10, right? Then what is it here? 5, 5, 25, 25 into 15. 25 into 15. 375 obviously into 10 power minus 1. So total answer how much I am getting here? Tell me. 375 into 10 power minus 1. So 37.5 I can write newtons. Or else, which is easier? This is not correct answer. This is not correct answer. This one, what buddy? Achha, we got a 50 centimeter, right? So here how much will be? Minus 2 centimeter, right? So it will be cube, I can write it, or else it will be written as 337.5 into 10 power minus 2 newtons. Can I get it like that? Yes or no? Which answer would be correct now? Correct, right? Okay, okay. Minus 4. Hmm. Then which answer will be correct, buddy? So what is the answer I can try it here? I can try which one here? 37.5 into next 10 power minus 4 3 2 4. How it will be 4? Array 375 into 10 power minus 1 into 10 power minus 2, can I write? Oh, all is written in like that. Okay, then 4 is correct. So which option is correct now? D? Yeah. 375 into 10 power minus 3. So total answer will be, what is it here? In terms of 3 point I have to write. So I can write 0.75 into 10 square into 10 power minus 3. No, 4 also not coming, right? L is actually not in centimeter, I guess. L is in meters. 50 mm you can consider. 50 mm means what is it here? It will be cube. It will not come here. I'll solve it again. Listen. Fm is equal to, what is it here? B square L square and V divided by, what is it here? R. So B is how much here? 0.5 na? 15. I can write B is equal to 15 into 10 power minus 2. 15 into 10 power minus 2 whole square. L square is how much here? 50 centimeter na? 50 into 10 power minus 2 meter whole square. Velocity is 2 divided by r is how much here? What is r I gave? 3. So total answer is 225 into 10 power minus 4 into 50. Here I can cancel one time. So 25 into 10 power minus 2 divided by into 2 divided by what is that here? 3. Got it? So now what is the answer I can get it here? 3, how many times I can cancel this one? 3 sevens are, 3 fives are. Yes or no? And then here 75 into 25 will be how much? 75 into this is how much? 50. Yeah? 50 into 75 into 50 how much here? 3750 into 10 power minus 6. Yes or no? How many digits I need to remove? 1, 2, 3. 3. Yeah? So 3 means what is the 3? 3.75 into 10 power minus 3 will be the correct answer. Option A will be correct. Clear? I didn't square it earlier. Shall we move on? Shall we move on? Do this question. Wait. Do this question. Pressing a K means what is it here? Closing a key. Pressing a K indicates what is it here? Closing a key. So what is the answer now? Tell me. Pressing a key means here logic you should understand immediately after the connection. Yes or no? Will it pass any current now immediately? No, there is a current will be divided here. Obviously, this is a I1. Let me write it. Then it is a, let me say I2 and this is I3. Let's say. Yes or no? I1 is equal to what is it here? I2 plus I3. We know that according to the Kirchhoff's law KCL. But this immediately we cannot increase or decrease the current. So what happens here? I2 will become 0. So I1 is equal to what is it here? I3. So in this circuit line, no current will pass in this one. No current will pass. Then I1 value will be equal to what is it here? Here already they have mentioned is I3. It doesn't matter. So now what happens, buddy? Only I1 will be passing through it. Yes or no? So I1 is equal to what is it here? Voltage divided by R equivalent. Voltage is how much here? 10 divided by R equivalent is 6 plus 8. So 10 divided by 6 plus 8 is how much here? 14. So it will be how much here? 5 divided by 7 ampere. Which answer is correct now? Yes or no? Immediately you cannot increase or decrease the current from this one. Then hello ma'am. Yes ma'am. Hello ma'am. Tell me. Respect the class teacher. Homework in a group. Okay. So I should beg all the teachers to give all the homework. What should I got it. Okay. Definitely, ma'am. I'll do everything. Don't worry. Definitely. Yeah, I'll update ma'am. Definitely. Don't worry. All the class work, ma'am. All math, chemistry, and biology, and physics.
Not only for 11 Neet.
11 Neet. Consent teacher, what is doing, ma'am? A consent teacher will be there, right? No problem. I'll
I
update.
have to update 5 classes.
I'll update, ma'am. Whole school also I'll update. I'm very good at it. I have a superhuman powers and all. You don't know. Okay. I have doctors here. See, pediatrician, gynecologist,
Who is
cardiologist.
gynecologist, sir?
Where is she? Oh, there. There is Dr. Harini. Okay. Sadhana. There is mental specialist also here. Ambulance driver. How many you want? I have many things. I can do it. Don't worry. Shall we, buddy? I forgot radiologist. Where is she? Where? Oh, very sorry. Okay. Radiologist. Oncologist, anybody? Can you do this question? 15:35. Come on. 2, 3 question will do it. I'll leave you. Chalo fast. Same answer. Expected. Give me the answer fast. I square. L I square. Inductor energy stored formula unnada. How much? What is the inductor energy formula? Li square. Yes or no? How do you find the I? Because initially though no current, but slowly it will pass a current through it after some. So they didn't mention anything. Stored they said means it may be working for a while, right? So what is that? I is equal to voltage divided by resistance. Voltage is how much we have here? 10 divided by resistance is how much? 2. So 5. 5. What is it here? Amperes. Now use it here. Half into L is how much? 2. And I will be how much here? 5 square. Answer will be how much? 25 joules. Done? Is it correct? We studied, right, inductor last time. Energy last Sunday, Saturday. Saturday we studied. Next, write down. Finish it. Finished? Shall I move on? Can you do this question? Just draw the diagram and you see that that is loop is going on. I told you already 1 hour we discussed this question. Is there any flux changing here? Then how much current will be there here? If there is no flux change, there is no EMF induced. Yes or no? EMF is equal to minus change in flux divided by change in time. There is no change in flux here. 0 divided by 0 will be what is it here? 0. Now I is equal to EMF and the resistance of this loop. What is the answer now? 0. So what is the answer, buddy? 0. Got it? This there is no flux change. If the coil inside the flux, no changing. But whenever it is entering, flux will change. Whenever it is going out of the field, flux will change. Inside, no flux will change. So no EMF will be generated. Am I correct here? Shall I move forward? Done? Can you do this one now? Last question. After that you can leave. The inductance L and resistance R are first connected to the battery. First connected to the battery. After some time the battery is disconnected, but L and R remains connected in the closed circuit. Then the current reduces to how much here? 37% of initial value. In, they are mentioning in. Hmm. Earlier, situation 1 la, what is the situation 1? They are connected, means it will store the charge as a magnetic field, and one resistance is there, and here one battery, something like this I am trying to mention. Okay. Now what happened here? Suddenly, this is there earlier in the starting of this question is, what is it? First they connected in the battery. After some time, the battery is disconnected, but L and R are remaining closed. Means what is it meaning here? So this one here, this battery is, this is your cancelled, but still they are connected. Yes or no? They are still connected in the series. Now then current was how much it was reduced here? 37% it is reduced to initial value. Then in asking means time they are asking. So what is the time? So I told you reduction formula or increment formula already we discussed. What is that formula? Here I is equals to I naught times of e power minus, yes or no, R divided by L into T, yes or no, or else I told you that time constant formula I naught into, I can write it as e power minus tau divided by t divided by tau. I can draw, I wrote it, yes or no. Anyone you can use a relation. So now what happened here? I is equals to I naught times of e power minus R by L into T. This is what we have it, yes or no. But what happened? This value they have already given. How much they have given here? 37% of initial value they have already given. 37% means what is that here? 0.37 times of I naught, which is equal to what is that here? I naught into S or no, e power what is that here? R by L into T. Can I write like that? Yes or no? Next step, what is that here? I and this one will be cancelled. What is that here? I and this one will be cancelled. Next, done buddy. So next, what is that here? So what happens here? Now this is log to the base e, which will be 0.37, which is equal to what is that here? Minus R divided by L into T. Yes or no? This value approximately, what happens here if I reverse it? Basically this minus value if I reverse now, T is equal to, if this is value I am taking it as completely some value of 1. Okay. So T value should be what is it here? Minus L divided by, got it? So almost every part, every corner of this chapter I have finished. Okay. And you're writing the second test here. So we may go for the next chapter. Okay, Monday or Tuesday, I may start the alternating current, which will take for 15 days. Okay, which is a big chapter. We'll try to do it as soon as possible. Okay, chalo. Thank you then. See you.